So in 5.3, it's talking about solving trigonometric equations. So let's go over some brief information before we can actually go into it. Now, in the beginning of the section in the textbook, it talks about use algebraic techniques to solve. So basically, anything that you have done in algebra to solve any given equations, regardless if it's linear, quadratic, or higher degree. So you're basically using just the basic algebraic techniques just to solve for the variable. So as described in the textbook, in lesson 5-2, meaning 5.2, you verify trigonometric equation called identities that are true for all values of the variable for which both sides are defined. In this lesson, we'll consider conditional trigonometric equations, which may be true for certain values of the variable but false for others. So, what it means by that is that there is a selective values for x that is true for the solution, while there are others that are not, depending on the given domain. So, below, next is a example of a graph. So what it says, consider graphs of both sides of the conditional trigonometric equation cosine x equals 1/2. The graph shows that cosine x equals 1/2 has two solutions on the interval 0 to 2 pi. X equals pi over 3 and x equals 5 pi over 3. So what it means that the value of x, that's basically asking at what angle in degrees or radians at one angle when the cosine value is equal to 1/2. So if you were to look at the cosine graph here, you would look for where the y value is 1/2. So here is one example where y equals 1/2. That means that at the x value, pi over 3, that's the solution. And you would continue looking for all the other ones, where there's another one right here at x equals 5 pi over 3. And then there's two more at the very end of the graph function. Now, as you can see that the graph has arrows on the end, so that means there's infinite amount of solutions. But why did it give us two solutions, which was pi over 3 and 5 pi over 3? Well, I mentioned before, it depends on the given domain. So our given domain is when it says solution on the interval between 0 to 2 pi. That's your specified domain. So it means that what solution is valid within that given domain. So you're not required to give out infinite amount of solution. So you're just giving out what solution are valid for that domain between 0 to 2 pi. So right here it says, since y equals cosine x has a period of 2 pi, cosine x equal to 1/2 has infinite many solution on the interval -infinity to infinity, which I stated before. The additional solutions are found by adding integer multiples of the period, so we express all solutions by writing x equals pi over 3 plus 2n pi, and x equals 5 pi over 3 plus 2n pi, where n is an integer. So this ties into when you're talking about the graphs of sine and cosine, the frequency, the period, the phase shift, and the amplitude. So if you were to give a general solution, this would be the form. Now, rarely I will ask for the general solution, but if I do, basically, where x equals pi over 3, if I do one period one full cycle, it'll be over here, basically subtracted by 2 pi. So a difference of 2 pi. Same thing over here. If I were to do 5 pi over 3, which is in the middle, right here. So if I were to do one full cycle to the right, one full cycle over here, basically adding 2 pi. But if I go back in the middle where 5 pi over 3 is, if I were to do one full cycle to the left, I'm subtracting by 2 pi. So the difference on the left and the difference on the right are the same, a difference of 2 pi. So it's the same thing if it was 4 pi, 6 pi, 7 pi. So that's why they gave you the general solution, pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. But as you are going over this, you would remember that it's talking about only in radians. So that's a clear indication that we're mostly going to be working in radians. So you're basically looking for what angles in radians that are valid solution on a given domain. So there's the first example here. Solve by isolating trigonometric expression. Now, what I forgot to mention up here is that you don't have to copy the whole thing. It's just the basic information, such as using algebraic techniques to solve. Basically, majority of the information in the second paragraph. But to be successful in this section, you need to know your unit circle. So expect to have quizzes over the unit circle and expect to study and memorize it, especially when it's going to be on the test. So you need to know the unit circle to be well prepared for the test. And the first example is talking about solve by isolating trigonometric expression. So our first example is 2 tangent of x minus square root of 3 equal tangent of x. So what it did is try to get all the tangent of x on one side. So it subtracted tangent of x from the right side and then subtracted to the left side. So 2 tangent of x minus tangent of x will equal to tangent of x. Then you're left with tangent of x minus square root of 3. So in order to get the variable on one side, the number on the other side, what they did was added square root of 3 to both sides. And when you do that, you get tangent of x equals square root of 3. Now the period, here's this brief description, brief paragraph. The period of tangent is pi. So you only need to find solution on the interval 0 to pi. The only solution on this interval is x equals pi over 3. The solutions on the interval negative infinity to infinity are then found by adding integer multiples of pi. Therefore, the general form of solution is x equals pi over 3 plus n pi, where n is an integer. Now again, right here is called the general form. Rarely I'm going to ask for it, as I stated before, but in the event that I do ask for it, or say a question on your college exam, on the TSI, this is basically what it means by general form. So how did they get pi over 3? So basically they're looking at the unit circle and they're trying to see what angle that gives tangent pi over 3. But as you recall, the unit circle only had two functions, sine and cosine. So how would they be able to give you tangent, or how would you be able to find tangent? Well, is what was covered in 5.1 and 5.2, the quotient identity. So once you know your sine and your cosine, then you should be able to find, using the quotient identity, which angle that will give tangent of x equal to square root of 3. But this was already covered in chapter 4 of which angles specify specific unique angles that would give tangent of x equal to square root of 3. So I would highly recommend to go back to your notes from chapter 4, especially that regards to the unit circle, and make sure to remember your trigonometric identities from 5.1 and 5.3. I will do more examples for solve by isolating trigonometric expression.